lot of this recitation will be using R directly, so I'll show you how to use the different functions in R. But first, I want to just go over the vocabulary that's in this recitation activity. So here we have the definition of a population. So a population is a set of units that we are interested in studying. So it's usually people, objects, transactions, or events. A variable is a characteristic or property of an individual experiment, individual experimental unit, or observational unit. So for example, if we're dealing with people, our different variables could be age or weight or height. A sample is a subset of the units in a population. So if our population is, all the females in the US, a sample would be, let's say if we took, we randomly selected 3 females from each state, would be an example of a sample. Quantitative data are measurements that are recorded on a naturally occurring numerical scale, and qualitative data are measurements that cannot be measured on a natural numerical scale. They can only be classified into one of a group of categories. So for example, if we're dealing with weight, that would be quantitative data because it deals with, there's a numerical scale. But let's say if we're dealing with color or like different colors or let's say a person's race, that would be qualitative data. Central tendency is the mean, median, and mode. Variability is range, variance, standard deviation, and interquartile range. And the shape could be symmetric, skewed to the right, or skewed to the left. So this is the different vocabulary. Let's get started with the questions. So we're going to be using the nutrition study data. And in this first question, our X is going to be the age from that data. So let me go to R. And here I have downloaded the nutrition study CSV. So if I wanted to just see what that looks like, I could type a header of nutrition study. Oops. Let me click this view file. Oh, here's all of the data here. And if I go to, oh, that's all my history. Oh, here we go. That's what I wanted. So this is what our data looks like. So we have our ID, which is 1 through, goes on and on, 315. So we have 315 different subjects or people. So our sample size is 315. We have their age listed, so that would be like a numerical variable. We have if they smoke, which is yes or no, so that would be a categorical variable. And then we have the other different variables like vitamin, calories, fat, fiber, so on and so forth. So in our first activity, we're dealing with our X is going to be the age. So this column here is what we're interested in. So to do that, you basically, I'm going to name X as, I don't know why this isn't working. Maybe I need to, for me earlier. Oh, import data set. Let's see if that'll work. Import. There we go. Now it's imported. Now I can do what I wanted to earlier. So I'm going to name X as the age. So if I wanted to print what X looks like, just to see what I'm dealing with, here are all of the different ages. So the first person's age in the sample is 64, then 76 and 38. And if I look at the like the Excel sheet, we have 64, 76, 38. So this is this row here. We're dealing with age. And so the first question for us is to find the mean. So we can find the mean by typing mean X, and that will give us the mean of 50.14603. So remember that what the mean does, it's basically adding up all of these different numbers, all of the different ages, and then dividing it by the total number of people in the sample. All right, so next, part B, we want to find the median. So the professor has we can do sort X to just have, basically it takes the list here of ages and it sorts it from smallest to largest. So if we were, for example, doing it by hand, which you would never have to do it by hand for this many. But if you were doing it by hand to do the median, you would cross off the lowest, cross off the largest, and then eventually you'll get to some number in the middle. But we're going to use our computer to just type, oh, we already did the mean, sorry. To do the median, we can just type median X. Oops. And that gives us 48. So our median is 48, which is kind of what we would expect because it's somewhere in the middle. All right, sorry for the extra noise in the background. Next, here, I'll wait a second. All right, so next we need to find the first quantile. So if I hit quantile X, it'll show what, the first quantile is, second, which is the median, third quantile, and fourth, and so on. So here for quantile 1, we can see that's the 25th percentile, and that would be 39. And then part D wants us to find the third quantile, which in this would be the 75th percentile, which is 62.5. So part C is 39 and part D is 62.5. All right, so now we need to find the 29th percentile. So you can still use the same function, which is quantile, but here I'm going to specify what quantile what percentile I want. So I want the 29th percentile, so that gives me 41, which the 29th percentile will be somewhere in between here, we can expect, and 41 is indeed in between 39 and 48, so that goes with what we would expect. So that's part E. Now on to part F, we want to plot a histogram. So we're going to use the hist function. So hist X, and here is our histogram of X. So for example, this is the frequency on the y-axis, and on the x-axis is our x's. So for example, if we were to say, like 40, shows up – 50 times the data. or not 40, but it depends on the what's it called, like the bin width. Um, but this is the frequency. So how many times that X shows up in the data. And we can also do a box plot by doing box plot X. And here is our box plot. And here's your quartile or quantile 2, quantile 3, quantile 1. So that this should match, those lines should match what we have here, which is what we have. So for the 0 percentile, we have 19, and then we have for the 25th percentile, we have 39, and then for the 50th percentile, we have 48, 75th, we have 62.5, and then the 100th percentile is 83. So that's kind of how to read the box plot. And then there's also a hint in part G. To access the element X in position 5, we can do X and then these brackets and put 5 here, and that gives 72. So here, if we look at what our fifth person in our sample is, their age is 72. So this is how you would find it using like a function in R. So you would use the bracket. And right, so now let me go back. So we did all of this. And now we are on this question. So we're going to consider the first 6 measurements from the nutrition study, vitamins. So now we're using the vitamin column, and we're going to make that our Y. And we're interested in using vitamin 1 through 6. Okay, so I'm going to label this as my Y. If I print my Y, this is what I get. But also, I realized I forgot to do this ahead of time. We're only interested in the first 1 through 6. So I need to change this to a bracket 1:6. So now, if I make this my Y, and I print my Y to see what it looks like, this should give us the first 6 measurements: 1, 2, 3, 4, 5, 6. Okay, so now we can, so I printed my Y, that's what we're working with. And if we want to double check that it's giving us the correct thing, we can look at vitamin, and we're interested in only the first 6 people. So we have 1, 1, 2, 3, 1, 3. So that matches what R gave us. But this is where it would be in the table. All right, so we have to find the mean, the range, the variance, and the standard deviation. So we can hit mean, or type in mean Y, and that gives us our mean. We can type range Y, and our range, so our lowest number is 1, our largest number is 3. So to find the range, we would do 3 minus 1. Sorry about that. So our range is 2. Next, we have to find the variance. Oops, sorry, I did it wrong. So for variance function, you use VAR. So the variance of our y is 0.9666. And then our standard deviation, we can do the square root of our variance. So square root of our variance y. And that's our standard deviation. All right, I'm just going to update my paper real fast because I initially didn't do the first 6. So just give me one moment. So our mean is 1.8333. Our range is 2. Our variance is 0.9666, repeating, and our standard deviation is the square root of the variance, which is 0.9831921. Okay, so now we want to multiply each value of y by 3 and repeat our a. So I'm going to name this new variable, and I'm going to say y mult is our y times 3. And if I want to print my y, if I want to print y mult, which is the new variable I just defined, you'll notice that I took every entry and multiplied it by 3. So I have 3, 3, 6, 9, 3, 9. So I basically took 1, multiplied it by 3, that's 3, like 3 multiplied by 3 is 9, so on and so forth. Okay, so now we need to do the same thing. Find the mean, range, variance, and standard deviation. So I'm going to just copy and paste. It's the same functions, but notice that I put my y mult in there. So for our mean, we get 5.5. For our range, we get our lowest number is 3, our largest is 9. So to get the actual value for the range, you're going to do 9 minus 3, which is 6. Our variance is 8.7, and our standard deviation is 2.94956. So I'm just going to update this again because I had initially wrote it down wrong in my notes. So give me 1 second. 5. $2.9. Okay. And then now we're going to take our original y. So we're going to take this y. And now we want to subtract each value of y by 4. So I'm going to name a new variable, and I'm going to have it be called y sub, which equals y minus 4. And so if I print y sub, I basically, subtracted 4. So 1 minus 4 is -3, 2 minus 4 is -2, 3 minus 4 is -1. So this is our new data we're working with. So now we want to find the same thing. So mean, range, variance, and standard deviation. So our mean, and I'm going to update this as I'm talking, save time. So we have our mean as -2.16667. That's here. Then we have our range. Our lowest number is -3. Our highest number is -1. So we'll take the max minus the min, and that'll give us 2 is the range. And then we have our variance is 0.9666 repeating, and our standard deviation, which is the square root of the variance, which is 0.9831921. Okay. So now the next thing in the activity states, okay, so consider the answers to parts A, B, and C. What seems to be the effect on the mean, variance, and standard deviation? So if you notice that part A, and let me see, if I run this, it might make it more concise looking here. Yeah, even though it's kind of all coming together. But so here's part A, here's part B, and then here's part C. So what can we notice about the mean, variance, and standard deviation? What seems to affect it? So here we have the mean as 1.833. Part B, we have the mean as 5.5, so that's larger, that's something different. And then we have the mean here as negative 2.1667. Did I? Hold on. The standard deviation, so for parts A and C, the standard deviation and the variance is the same. And notice that the range, which is 2, is the same from parts A and C. Our variance and standard deviation is much larger for part B, which is right here. But our range is 6. So with the larger range, our variance and standard deviation is different. So what we notice is that the range affects what seems to be the effect on the mean, variance, and standard deviation is the range. And for some reason, mean y, well, mean y. And that also seems to be affecting the mean as well, the range. Except here, I don't know why I'm getting something different, because initially when I did it, I got the same mean. Hold on. Oh, but the mean would change because our values are still different. So that's correct. Sorry, I was just second guessing myself. Okay, so the answer to, oh, this is the wrong PDF, doesn't have it. So the answer to this question here, part D, is the range. All right, so now oh, and then the last part is, so in general, let y equals ax plus b. Then the mean of y equals ax bar plus b. So here a and b are constants. So yeah, the mean of y is ax bar plus b. The variance of y, so you would basically when you take a constant out of the variance, it becomes squared. So you have a squared times v times x, and then the standard deviation is the absolute value of a times the standard deviation of x. Okay, and I think that concludes this recitation. So thanks for watching, and I'll see you for recitation 3. Bye.